All right, so this is our basic Arduino class for basic electronics and Arduinos for the trainers and instructors. A lot of this stuff is what you guys are going to deal with in the classes, but we are going to kind of skim through some of this stuff just so we can get to giving you guys a chance to play with the actual hardware. So let's go ahead and skim through a couple of these slides. A lot of this stuff is basically just asking questions, trying to get the kids to think about why electronics are important. The biggest thing to remember is that electronics are used everywhere. I usually have the kids name some things that they think would involve microcontrollers or electronics, and really most of what comes up is people say things like computers and of course phones and tablets, but I also like to remind them that even a thermostat has a lot of electronics in it, a TV remote control, even headphones, all of the small things like watches that you don't really think about all run off of electronics as well. This is a video that I don't really show to kids, but I definitely show to people to motivate. But I do talk about this with some of the kids about how electronics can help people out. This is a video from a guy who actually has Parkinson's, and he has the neural pacemaker. The neural pacemaker, basically it just sends an electrical pulse into the brain, which actually allows him to move properly. Anyone who's got advanced stage Parkinson's doesn't have control over their muscle movement, and by simply pulsing this steady stream of electricity into a certain part of their brain, they're able to completely regain mobility and not be disabled anymore. So that's just one example of how technology can affect our lives really drastically. That while I typically won't show this video because it is a little disturbing, I will talk about that a little bit. And electronics are not just really cool stuff that we deal with. This is a video, and I'll play a little bit of this, that talks about how electricity works. This is talks about how electricity works in a battery. So let me just play a little bit of this so you can get an idea.
The industrialized world gets even less attention. It's the ability to put Zeus in your pocket. The battery is the silent, unsung hero of modern man. And batteries are everywhere. Just go to a concert. The ability to store some energy, walk around with it, use it when you need it, has had a profound effect on our lives and our cultures. The battery is what gives us instant images. That has made things possible, like internet memes and revolutions. There are many different types of batteries, but they all pretty much work the same. Let's look at a cell phone battery. Now, to understand how a rechargeable battery works, you need to know a little background. This is an atom. The inside has a clump of positive charged particles in it called protons. The outside is a buzzing cloud of negatively charged particles called electrons. And electrons are the key to electricity. The movement of electrons is what makes the lights go on. So how do you get electrons to move through a wire if they're happy just buzzing around as part of an atom? Well, it turns out that electrons just want to be happy. And for electrons, happiness is being at a lower energy level. Think of it like this. Let's say a high energy level is like working at a high stress job, and a low energy level is like sitting at home stress-free. If your boss said, hey, do you want to work from home? You do that. And if your boss said, hey, do you want to stay at home and still get paid for not doing work? Who wouldn't do that? Well, electrons do the same thing. For electrons, buzzing around some atoms is like working in a high-stress environment. And fussing around others is like sitting at home and getting paid for nothing. A battery basically gives electrons a path to a happy, stress-free life, but makes them work for it, which we'll get to in a second. Here's the atom again. As I mentioned earlier, there's a positive charge part and a negative charge part. In a normal atom, there's balance. The number of protons equals the number of electrons. But if an electron leaves this atom, now the positives outweigh the negatives, and we're left with a net positive charge. Add electrons, and we're left with a net negative charge. These are ions. An ion is simply an atom that is no longer neutral. It has a charge because it has either lost or gained electrons. So while electrons want a low energy, stress-free life to be happy, ions just want to be neutral. And they do this by finding an opposite charge and sticking together. The heart of a battery is electrons and ions trying to achieve happiness. Let's look at what parts make up a generic rechargeable battery. First, you need two different materials. One that for an electron is like working 80 hours a week for an abusive boss, high energy level, and the other is like sitting at home collecting paychecks, low energy level. In other words, given the option, an electron in material A would rather be in material B. In fact, if you just put these two materials together, electrons would just hop from one to the other. They would take a shortcut. To stop electrons from taking the shortcut, you need to add a barrier that forces them to take a detour. This detour is the circuit. In other words, the thing you're powering with the battery. And finally, you need something for ions to move around in. Here's how it works. With the circuit off, electrons in material A are stuck in their high energy, high stress atoms. Out of reach and on the other side of this electron barrier are material B atoms, which would offer an easy, cushy, low energy level position. Let's turn the circuit on. Now you've offered electrons a path to happiness. Since they can't go any other way, they begin flowing from the circuit to material B. Back at material A, the atoms are losing electrons because that's where the electrons are coming from, and they begin turning into positively charged ions. As we mentioned before, ions always want to be neutral, so these guys need to find a negative charge, so they go to where the negative charges are, in material B, where all the electrons are going. You'd think that these ions would just meet up with their lost electrons and become neutral atoms again, but unfortunately the electrons are way happier where they are now, so the ions have no choice but to kind of mingle with the atoms of material B. So what we've got is kind of a mishmash with B atoms mingled with A ions. As the battery discharges, electrons and ions are making their way from A to B. When you can't fit any more material A ions into material B, the battery is fully discharged. To recharge the battery, you just do things in reverse. Instead of a circuit, you're putting an energy that forces the electrons back into material A. The ions then leave material B and rejoin their lost electrons, and the battery is ready to discharge again.
All right, so that's the basics on how electricity works. Of course, it's with a battery, but I usually have kids actually act that out. So we have them go from one side of the room. I'll have the instructors on the one side. They'll be the material B, and then material A will be the students. And then when we flip the switch, then the students have to basically run over. Of course, with smaller kids, they're not going to understand the whole analogy of having a high-stress job. So I use the analogy of they've all been at a party, but the part time, and now it's time to go home. And the only way you can get home is to go over to material B. So we'll do that. We'll also talk about different to put in the way of the electrons to actually make them do stuff. We actually review over here what we learned in the video, and then we talk about what we can make these electrons do, and that gets into the conversation of things like inputs and outputs. So we can get them to name a few things that electrons can do, and then we start talking about output. So output examples are things like motors, lights, LEDs, heat. So the basic ones are sound, light, motion, and heat. We then talk about inputs. Now, outputs, kids tend to have a really easy time coming up with. But outputs, inputs, kids seem to have a little bit more trouble with understanding. So the way I describe it is an output is something that our microcontroller or that our circuit is giving to us. So it's information that it's giving to us. Input is information that we're giving to our circuit. So things like buttons, things like microphones, light sensors, those are all devices. So it's good to start getting kids to think about this, because this will they'll hear these terms once we get into programming the Arduino, and it's important that they kind of have a basic understanding, and that's one that they do tend to have a little bit of trouble with. We do play this video, which I believe this is a video on schematics. We do touch briefly on schematics and show kids what some of these symbols look like, because again, once we move into programming and actually building these circuits, it's easier if they have an understanding to be able to follow along. And then we do an exercise where we have the kids make the electrons do some work. We have them pick a couple of examples of outputs, again, because outputs are easier to act out. We display a couple of symbols. So these are some basic schematic symbols for some basic outputs that we can have the kids choose from. A couple of things to note is that the resistor, resistors are typically used for constricting the flow of electrons and reducing it. Now, the reason I have reason I have resistor listed here as an output is because the way that a resistor restricts, because the resistor restricts the flow of electrons, that generates heat. So when you want to heat something, the best way to do it with electricity is to slap a resistor in there. And the resistor will generate heat, which is a form of output. And that actually came about from a kid that was mentioning heat as being an output. And when I researched what a heater is, really all a heater is just a resistor that's trying to resist the flow of a lot of electrons. Going back to this, so what the exercise that I usually have the kids do, which can get a little rowdy, but they definitely enjoy it, is I have them actually pick one of these outputs and draw it on a sheet of paper, and then we actually pick some people who picked those outputs and have them come up with a behavior for them to do when the electrons are going past them. And then we do the same exercise. And the electrons run from A to B, but this time they have some of these outputs in the way, and when the electrons go by, then the motors have to spin around, and the LEDs have to wave their hands, and the buzzers have to make a really annoying sound, which of course the kids really love. So that's a good way, and I found that actually the kids really understand what this stuff does and how this stuff works once they go through and act that out. The next thing we get into is the breadboard. The breadboard can be a little challenging for the kids to understand, and that has consistently been something that's been a lot of trouble with getting the kids to understand. So we'll do a quick overview so you guys all understand. This is a video that kind of explains what a breadboard does and does describe in a lot of detail what we're gonna go over here. But I will actually show you guys. Let me just end my screen share here for a sec. All right. So this is my this is the breadboard here. This is similar to what you guys are going to be using, but I believe the ones that we have for STEMPath are a bit shorter, but they work the same way. And essentially, the way the breadboard works, bring up my drawing tools here. So essentially, the way the breadboard works is all of these pins are connected here, but they're connected in certain ways. So basically, all of these pins in that top row all the way to the end are connected to each other. And then all of these pins all the way to the end are connected to each other. Same thing on this side too. All of these pins are connected all the way down the line. And all of these are connected all the way to the end. So these are typically used for your common power and ground. Power and ground are going to be the things that you're going to jump into your circuit the most. So that's why they have so many holes with that. Typically, the red is going to be our positive. The blue is going to be our negative, and it does even have them marked over there. Either one of these sides, you're more than welcome to use. But if you connect power and ground to this side, you then have to jump. You'll have to jump the wire to here in order to provide power and ground over to this side. These two rails are not connected to each other. All of the holes are connected down either side though. Now, when you get into the center of the board, it's a little bit of a different story, because now your holes aren't connected in this direction. They're actually connected in this direction. So all of these holes are basically connected to each other in this direction, but they don't pass this line down the center, this kind of trench over there. That's a different set of connectors. So these are separate, but these holes are connected over here. But just keep that in mind that this is a barrier right there. So if I want to bring, if I want to connect these, I'm going to have to do a jumper to connect those together. Now, because of that, that's a really important thing to know, because this microcontroller, which we're going to be using, it's got a bunch of pins on this side, and then it's got a bunch of other pins on this side. So we don't want the pins on this side to connect to the pins on this side, so that's why we have it spanning over this gap right here. So I can connect anything into any one of these holes right here, and this will connect to that pin there. Meanwhile, if I'm on this side, I can connect to any holes here, and that will only connect to that pin there. So that's, you may have to explain this to the kids several times and kind of work with them. This definitely has been a big struggling point with teaching kids how to build these circuits. So let me just clear that out. And now we're going to go ahead and start building some of these circuits. So we're actually, we're going to talk a little bit about some of the things that we're going to use. So let me just bring up my screen share again. All right. So this is actually the exact breadboard that you guys are going to be using. Again, all of these guys are connected in the row here. All of these guys are connected like that. Next thing we're going to be using a lot is jumpers. So what jumpers do is jumpers are basically just a really easy way for wires to connect one pin to the next. The ones that we are mostly going to be using are called male-to-male, meaning they have this metal pin in here so that they can go into one hole in the breadboard and then connect it to another. And they're literally just for connecting one thing to another thing. Now we are into the FTDI Programmer. This is the device that you guys are going to be using to program the microcontrollers with. It plugs into the computer via the USB part, which is that yellowish part over on the side to the right. The black part over on the left with all the pins coming out, those will actually connect up to the board. And there should be some pins. Actually, I don't know if there's pins on the chips for spin, but there should be some pins that can fit into the holes on one side of that board, which we'll get into later. But in order to start with the basic electronics, we're actually going to use this device to provide power rather than hooking up a battery. So you'll notice that I have called out here the ground and power pins. Now on the FTDI cable, they are actually marked here as VCC for power and GND for ground. But the wire colors, actually, if we are using a different FTDI cable, it's basically going to be the black wire is ground, the red wire is going to be our power wire. Now we get into a little bit of information about LEDs and how those work. This is a diagram of a typical LED. Occasionally they do have these flat sides here, but don't ever count on that being consistent with every LED. The easiest way to tell whether an LED, which side is positive and which side is negative, is the positive is always going to have the longer leg, the negative will always have the shorter leg. Now that's really important because an LED is a special device called a diode. It's specifically LED stands for light emitting diode. And the special properties about a diode is it will only allow electrons to flow in one direction. So you can see this is the symbol that you would have on a schematic to indicate a diode. The two arrows basically show that this is light that's coming off of it. But this arrow with the plate there is actually the symbol for a diode. And the arrow kind of tells you what it does, because the arrow is the flow of electron, it's an electron trying to go in this direction, and then it has a wall that stops it from going in this direction. So what the symbol is telling you is that electrons can't go in this direction. They can only go in this direction. So LEDs work the same way. Electrons can only go in one direction, and that means that an LED has to be plugged in a certain way in order for it to turn on. If you don't have it plugged in the right way, it actually won't light up. So that's important to know, that the positive end needs to go to positive, and the negative end needs to go to negative. Next, we're going to go ahead and actually plug those in now. So let's go ahead and we've got a schematic here. You guys can follow that one. I'm going to switch over to my camera view so you guys can see me plugging this into my board here. So now what I'm going to do is I've got my FTDI cable here, and I don't have exactly the same one that we'll be using for stem paths. And I don't have exactly the right color wire. Ideally, you should be matching up the colored wires if possible with what's available, but I'm just going to use some wires that are kind of similar. So I do have this orange wire, which I'm going to plug into my red wire connection, and this blue wire, which I'm going to plug into the black wire connection. So just like that. And now I'm going to plug my blue wire into that one. Actually, I'm going to do it towards the end so I have more room. And I'm going to plug my orange one, or my power wire, into this one. And so now I have my two wires plugged in there. I have power and ground running into my board now. And what I can do is I can simply take my LED and take my long leg, which is positive, and plug it into the red line. And the shorter leg I can plug into my ground line. And sometimes it takes a little bit of wiggling, but you can see that now the LED is turned on. So do you guys get that? Well, we don't want to plug into the board yet. We just want to do it into the side of the breadboard. And actually, let's stay away from the board at this point and do it on the opposite end. All right. So it looks like you guys are getting it. All right. So yeah, people do have a little bit of trouble sometimes getting the LEDs into the board. What we can do, it helps to have pins that are as straight as possible. And over time, trying to jam stuff in, it can make them a bit crooked. So what we want to do is straighten things up as much as possible, so they go in there as easy as possible. But as you can see, if I plug it in the right way, it will actually light up. But if I turn this around and plug it in the wrong way, nothing happens. Because again, this is a diode. Electricity will only flow in one direction. So now we're going to add to that LED, and we are going to do a button. And this is a diagram that we've got for the slides. Again, this is not necessarily the button that you guys are going to be using, but this is a pretty typical button, and no matter whether it has this yellow button on top or if it's just one of the standard black buttons, they are going to work the same way. They typically have these 4 pins, but as you can see through the red line here, these 2 pins are actually connected to each other. So you'll have one side that 2 pins will be on right next to each other like this, and those 2 are the ones that are separated. The pins that are on opposite sides of each other, those are not separated. They go all the way through. So that's very important, because if I connect something to this pin here and then connect the other side to this pin here, the button won't actually work because these 2 are connected. So in order to use the switch, I have to connect one end here and then the other end over here, and then it will actually work. So we're gonna go ahead and build a circuit now with that button in place. I'm gonna switch back to my camera so that we can see that. And we're going to need another wire here. So I'm going to place this button right in the center. And again, you'll notice that this has the two legs that are connected with each other. And it does have, they typically have these little pins here, and that fits perfectly right in the center of that little trench that goes through the breadboard. Now sometimes you do have to push this rather firmly down until it seats properly. But what we're going to do now is we're going to connect this LED to one of those legs. So let me see if I can get this so the camera can see it. So what I'm going to do is these two legs back here, these two pins, I'm actually going to go into one of those with my, I got to remember which one. So my long leg is going to go into one of those pins, and the other leg is going to go right outside of the battery, or sorry, right outside of the switch there. Now I need to connect those to my power and ground. So what I'm going to do, looks like my power and ground got unplugged here. So now I'm going to take another couple of wires. I'm going to stay consistent, so I'm going to keep my orange and my blue. And what I'm going to do is my orange is positive, and remember my positive connection is connected to the one side of the button. So on the other side of the button, over here, I'm actually plugging in my positive power, and then I'm going to tap this right into my positive line. Now I'm going to connect the other end of that LED into negative. And now when I push this button, what's going to happen is it's going to complete the connection between this positive and the positive leg of the LED, which should turn it on. And as you can see, the LED turns on when I push that button. Now here's what I was talking about with the legs on either side. I can take this power and I can put it on the other side of the board here. But see, it's still at that leg that's farthest to the left. And that still works. If I press the button, that still works. But now if I take this and I plug it into the one on the opposite side, see how the LED lights up? So that shows you that this pin, the two pins on the right, are connected to each other. And it's only the pins from the right to the left that are not connected. And that's, again, another common problem that I've seen with kids not understanding, is that they'll plug it in to this same one and then push the button and absolutely nothing happens. So just make sure that that is plugged in. Again, it doesn't matter if it's plugged in to the bottom or if it's plugged into the top. They'll both work. All right, so that is the basics with using the button. Couple of things that makes this really important is this actually shows kids about analog logic. Let me stop my share here, or start my share again. So this teaches kids about digital logic, and there's two important things that we want kids to understand. Digital and analog logic, because once we get in again to the Arduino and programming, that's going to be a really important concept for them to understand. Putting the push button in there, that's an example of digital logic. When the button isn't pressed, it's off, which is 0. You know, there's a couple of different ways that you can talk about that state. It's either on or off, high or low, or 1 or 0. So when the button is not pressed, the state of the LED is off or low or 0. when you press the button, the state of the LED is on, high, or 1. And those are all things that we're going to actually be getting into once we get to programming. Next thing we're going to do here is we're going to start with an example of analog logic, and that's going to involve our potentiometer. So really all we're going to do is we're going to switch out our button for our potentiometer. We are going to have to make a little bit of a change here. All right, so what we're going to do is we're going to pull that button out. And, or actually, let's leave the button there. Let's just move over to the side a little bit. Now, the way this potentiometer works is it's got a couple of connections here. So the important one to remember is that center one. So these two pins on the outside here, these are actually pretty much connected to each other. What we want to do is we want to connect one thing, just like the push button. We want to connect one thing to the center and then the other side of our connection to either one of these pins on the right or the left. Now we don't want to connect to the pin on the right and the pin on the left because it will just completely bypass it. We need to have one connected to the center and then one connected to either the left or the right. Doesn't matter which one. So we're going to plug that into our board with our 3 pins. And then we're going to take our ground, and let's go ahead and plug our ground into that center pin right there. Then we're going to take our LED, and we're going to plug the ground side of our LED into that pin right next to it. So just like that. I don't know if we can see that too well on the video. And then we're going to take our power, and we're going to plug our power into the other side of our LED, that positive light. So that's what we got. And now, if I point that LED up, we should be able to turn this knob, and you'll see that the brightness of the LED, you can actually adjust it by turning that knob. So what this potentiometer is this is what we call a variable resistor. So a resistor is a very important thing with electronics because it restricts the flow of electrons. If you think about it as like if you've got a bunch of water flowing through a pipe and you make that pipe very small, it's not going to let as much water through that pipe. So resistor is the same kind of thing. It's just a smaller pipe to not let as many electrons through as a regular wire does. What this potentiometer does is this works exactly the same as a resistor, except you can change the amount of resistance by turning it like this. This is a very common thing that's used in a lot of electronics. Anytime you've ever had to turn a knob or a dial to change a radio station or change the volume of something, it's a potentiometer that's actually doing that. This is an example of an analog logic. So this is an example of analog logic, which is something that we will definitely get into with our Arduino. In order to read values that are not analog is very important, because if you need to read a value that's not as simple as whether it's on or off, if it's somewhere in between, it's very important to understand how to read analog values just like being able to output analog values, which you can do as well. So once we get to the microcontroller, we will actually be doing the same thing. We'll be able to change the dimness of the LED, but we'll be doing it through software instead of having to use one of these components. A really great example that you can give of things that use analog values, definitely volume control. If they have a dimming switch in their house for dimming lights. Also, things that use analog values are temperature sensors, thermometers, wind sensors, light sensors. A lot of sensors that exist out there are going to use analog values because you want to know how much of something there is, rather than is there something or is there not something. And that's where analog really comes in handy. And that is pretty much it for the first part of our introduction to electronics. We are going to take a short break here before we start getting into microcontrollers, and then we'll start putting all this to use with programming.